And so once you've written down this problem, let's take a look at how we go about solving it. Now, first of all, we are increasing by a given percent each year, so that already tells me that we're going to be using that equation of a of t equals. So I know I'm starting with something that looks like that. Now make sure you do this in pencil though, because we're going to be changing part of this in a minute. So we got a of t equals, and then working with that same equation, the next thing we put in is the p value, the principal. What is the principal in this problem? It's 150, because that's what we start with. And then we're earning 4% interest per year. So remember where that comes from. We end up doing 1 plus the 4% divided by 100, because we turn the percent into a decimal. 1 plus 0.04 is where we get that 1.04. And then that's to the power of t. But in this problem, I don't know what t is. In fact, that's the purpose of this problem in the first place. We're trying to figure out how long it will take. That is, it's saying, find the value of t. So right now, I have a nice equation, but it's not helpful yet for actually answering the question, because the question is, when's it going to be worth 350? So I need to put that 350 into the equation. Where does it go in the equation? It's the a, yeah. A of t, remember, represents the amount of money at the end. It's the final value. So that's what I'm trying to make 350. Once we have this equation written out like this, now we're going to solve it using the same techniques that we've been using on other equations, but I've just given you the straight equation. So use those same techniques now, solve it through from there. All right, so now to solve it, remember that when we're solving an exponential equation, the very first thing we need to do is we need to get the exponential part by itself. So that's the 1.04 to the t. Notice then that means I have to get rid of the 150. Right now this is 150 times the 1.04 to the t. So what do I do to both sides? Divide, yeah. We divide both sides by that 150. When we do that, yes, you'll use your calculator for that. It gives us 2.3 repeating. And that's going to be an interesting point for us. I'm going to give you some insight about how to deal with that 2.3 repeating in a minute here. But let's go ahead and continue through seeing how we would then be solving it from there. So I have the exponential. Now I can go ahead and figure out what t is. What function solves for the exponent? Because there is a function type that exists solely for figuring out what an exponent equals. Logarithm. That's why logarithms exist, because when we turn this into a logarithm, log equals the exponent. And so doing that calculation of doing the logarithm tells us what the exponent equals. Getting it into this form, it's just a matter of using the same process that we've used with all of our logs before now. I'm rearranging it from exponential into logarithmic form. When we do that, of course, the number that's raised to the power, that's the base. Log always equals the exponent, so that's why it equals t. And of course, this number that the exponential equals, that's what goes into the log. When we calculate this then, it's going to tell us what the exponent is, because of course that's what log does. So now I need to calculate this. Remember that since this has some other base, in order to calculate it, I'm going to have to use that change of base formula. So the change of base formula is log divided by log. And of the two numbers, remember the base is always the number that goes on the bottom. So since our base was 1.04, that's got to be the number that's on the bottom. So it's log of 2.3 repeating divided by log of 1.04. Now we calculate that. And this is where we can get into a little bit of detail. Now, so you can check yourself and make sure you're going to be able to get the right answer out. You should be getting a number out of your calculator of about 21.60. But now, how do we get there? Because I don't want to round 2.3 repeating. In fact, if I do round 2.3 repeating, and if I just type in 2.3 instead, which is a tendency that I often see, it would give us a very different answer. It would give us 21.24 instead of 21.6. That'd make it look a lot more like 21 than 22. So How do you do that then? So now we can get into tips and tricks for using your calculator well. When you did this 350 divided by 150, your calculator was showing on its screen 2.3 repeating. We're actually going to use that whole number that your calculator is displaying to do the calculation, because the next thing we use our calculator for is this. Now, it just depends on what type of calculator you're using. If you're on a scientific calculator, you enter the number first and then press log. Well, if 2.3 repeating is already showing on your calculator, just press the log button there.
No.
But what if you're using a graphing calculator? How would you do it? If you're on a graphing calculator, you don't just press log and it gives you the number of it. So if you're doing it on a graphing calculator, instead what you'll do is you'll press the log button, and then most of you are using a TI-83 or TI-84. You would go second, the negative key. Because you notice right above the negative key it says ANS. So if you go second negative, it puts in whatever the last answer calculated was. So on a graphing calculator, right after you calculate this number, you'd press log, and then press that answer key, and it's going to do the log of that whole 2.3 repeating. You don't have to type in that whole decimal yourself now. And then you can finish it out in the parentheses, divide it by log of 1.04, and you should then be able to get the 21.60. So in this problem, we end up finding that it takes about 22 years for it to be worth about 350. So having seen how to do that one, follow that pattern now and use it to figure out how we would solve this problem. So again, start by writing the equation and then solve the equation. All right, so if I'm going to solve this, the first thing I need to do is I need to write the equation. And so I'm starting with that same generic equation that we normally start with. In this problem then, I'm just going to go through left to right and fill in what I know. In this case, do we know what the A value is?
No.
Well, remember what A means. A means the final value. We know where it should be ending. But now look at it carefully to see which one it is. We're looking to see when will the population fall below 3,000. So we're looking to see when does it reach 3,000. So 3,000 is our A value. It's our final value that we're looking to see how long it takes to reach. Next up is P, the principal. Principal is the starting value. As of this moment, as of the start of this problem, how many wolves are there? 5,000. That makes it our principal. That's our starting value. Right, next up, we need to look at the R value. Now, what is R here? It's going to be 8%, right? So I need to turn that into a decimal, so that would be divided by 100 is 0.08. But I'm not actually going to do 1 plus 0.08 in this case, though, am I? We're decreasing by 8%. Therefore, it becomes 1 minus 0.08. And then it's to the power of t because, remember, t is what I do not know. So it's got to just be to the power of t now. Now we're going to go and solve this problem. Now the first thing I would suggest you do in solving this, it looks kind of ugly if I leave it like this, but that's so easy to do. So do the 1 minus the 0.08. Write it out that way first. It's going to make your life a lot easier. And it makes the equation simpler. All right, now I'm solving the equation. So again, I want to get the exponential part by itself. The exponential part in this case is 0.92 to the t. That means getting rid of the 5,000. What do I do to both sides in order to get rid of the 5,000? Yeah, we divide. Because it's currently multiplying. If it's 5,000 times the 0.92 to the t, I'm undoing multiplication. That's why we divide. And if I do 3,000 divided by 5,000, I get 0.6. At least it's a nice, pretty number. Yes, it's a decimal, but it's an easy decimal to work with. So I got 0.6 equals 0.92 to the t. I've gotten the exponential part by itself. Once I've done that, I want to be able to solve for the exponent. What solves for the exponent again?
Log.
Log, absolutely. So I go back to how do I change it from exponential to logarithmic form, and I do so. I change it into log form. And then once you write it as a log, we do use change of base formula. So we then write it as a log divided by a log. When you do that, it's always the base that goes on the bottom, remember. And the base, it's always that number that's written smaller and lower. It's the first number you write. One way to remember, you notice it is written lower in the original log. And so in our fraction, it is written lower. So the base always goes on the bottom. Then this is what we're calculating. We're going to do log of 0.6 divided by log of 0.92. When you do that calculation, you should get an answer of about 6.13. So now, first thing we got to do, we got to write the equation. So I'm starting with the same equation that we always start with because I'm increasing by a set percent each year. First up, the a of t value. Do I have a final value that I'm targeting in this problem?
Yes.
Yes, I do. That's the 500,000. So I'm looking to see when this is going to be worth 500,000. Okay, so 500,000 equals P. P is next. P stands for principal. What is our principal in this problem? 300,000, absolutely. Why is it 300,000? Because that's what we're starting with. That's what we're at right now before we start building the interest. Then, it's going to be the 1 plus the R. So now we got to figure out what R is. Now, I know my rate here is 4%, but remember we always have to turn the percent into a decimal. So that means divide it by 100. 4 divided by 100 is 0.04, yeah. And then it's to the power of t. Do I know what t is in this problem? No. In fact, that's what we're trying to figure out. Because it's asking us, when will the house be worth that amount? So I know that t is what I'm trying to figure out. Now that I've written the general equation, now it's just a matter of doing the same algebraic process that you've been doing on the other ones. So step 1, go ahead and do that addition within the parentheses. Once you've done that, then we can worry about solving going side to side in the equation. So again, I want to get the exponential part by itself, so that means getting rid of the 300,000. When you divide both sides by 300,000, your calculator tells you that it's 1.6666. It's 1.6 repeating, basically. Now, when I wrote this down here on my paper, I wrote 1.67. That's just because I want to keep track of what number that was. But I'm not going to be using 1.67 in my calculation. I'm going to use that 1.6 repeating that my calculator is currently displaying when I do the calculation next. But before I get there, I need to change the format of this problem. I need to take my exponential and I need to turn it into a logarithm. Because that's how we solve an exponential. How we solve for the exponent. So I turn it into a logarithm. And then I calculate that using the change of base formula. So I'm going to do log of 1.67 divided by log of 1.04. But I'm not really doing 1.67, remember. That's 1.6 repeating. Remember that since your calculator is already showing that number, do log of that number. Either on a scientific calculator by just pressing the log button, or on a graphing calculator by saying log of answer. Either way. If all goes well, you're going to be getting an answer here about 13.02.